Welcome to this second week of the Festival Mixtur. This year with particular conditions, as you all know, because of the pandemic. But we are really happy to be here and to do the festival, even with less activities than planned at the beginning. But we think this is really important to keep going, to don't stop, and to continue with the creation, with the conferences, with art, and so on. So today we have the pleasure to say hello to Jonathan Bell. He was resident composer at the Casa de Velázquez, this French institution in Madrid. We already had meetings last week with Etienne Han and Laura Janelli. Also, they had been a resident there this year. And Jonathan will present his work. As you know, the content of the meeting is really free for him. And you'll see it is really interesting, and we hope you will enjoy it. So thank you for being here. Thank you, Jonathan, for adapting to this situation, online situation. I hope in the future you will be able to come in person.
Hopefully.
So, yeah, hopefully, and that's all. You have the your turn.
Wow, thanks a lot. It's a great pleasure to be here with you. Hello to Francisco Lobat, who I know, who's in the call. So I'll start. I just prepared a PowerPoint, and since we're not that many, just feel free to interact and add comments, questions, and things. There's like an element of tech, so if some are interested in what I'm going to talk about with Bach, for instance, and ask questions, and we'll discuss. If I say something wrong, just feel free. So, as you already know, my name is Jonathan Bell. I define myself as a composer, but nevertheless, I think I can't ignore the research component in my work. I'm still an associate researcher at Prism in Marseille, France. For them, the acronym stands for Perception, Representation, Image, Sound, Music. Richard Conland, who's currently the director of the lab, once described Prism as Jean-Claude Risset's last work. Indeed, for a very long time, Risset tried to convince French authorities that bringing artists and scientists together could lead to promising results. And well, as you all know, this is today seen as something quite pioneer because, well, art science is everywhere now. And so, yeah, he was sort of an example for that. Risset was sort of a father of computer music. So yeah, just a brief recap. Risset, he's often referred to as one of the fathers of computer music, again, together with Max Matthews, John Chowning, and David Wessel, who all were his close friends and colleagues. I find it interesting to stress that both his scientific knowledge and his musical intuition allowed him to explore timbre and sonority, which was still very enigmatic notion before the advent of computers. It's fun to think that 20 years ago, we just had 40 years ago, we had no idea what sound was. Like Risset sometimes talks about that. what in dictionaries you would see as the definition of timbre or sonority, that it was very, very vague. It's only with sound waves and stuff that we started to understand how it, what's behind that. Oh, that's a transition. So basically, this lab where I'm still associate researcher, Prism, they focus, because of Rissé, on sound synthesis, and this is probably why these days I'm playing with those machines. As I will explain later, this is not really my area of research, but it's still very funny. It's a bit like Max. Can you see you have oscillators? You plug another DAC. It's in VR, obviously. Yeah. So you have 3 oscillators there. Maybe you can hear the stereo as it's supposed to. This is another oscillator. Oh well. But well, I'm working on this like literally this week. I mean, in a little lab in Nice, and we tried this, which I'm going to show now. Basically, this VR interface can be used as a NIME, yes, as a new interface for musical expression. So this is how the VR looks from outside. I mean, we're just trying stuff. But this is not my central area of research. Like what I do really myself in research is more linked to that conference called Tenor. Yeah, technology for notation and representation, or CAC, computer-aided composition. That's what I'm going to talk about next. And now I'm going to just present you the slides I presented at SMC, Sound and Music Conference, like 3 months ago, I think. So it's going to be about Bach mainly. Maybe you're familiar with Bach. I will open the chat window here, so if you have questions or comments, since we're not so many. Bach Automated Composer's Helper. So my last paper was literally about Bach, although I'm really not a developer of Bach, but I'm a user. And I think this is just amazing. It's really changed lots of things for me. So I don't need to present Max MSP, I suppose. We saw Max Matthews, father of computer music. Max MSP was written as an homage to him. And so Bach basically works inside that environment, Max MSP. And what Bach does, because CAC, computer-aided composition, is very Lisp-based traditionally. So lists inside of lists like Open Music, PWGL, Patchwork, all these. And it's very hard to maintain. It's almost impossible, I think. It's like PWGL isn't supported anymore this year. And Bach has this abilities to, in some ways, port all that Lisp thinking of composers who worked with computers for 40 years, 30 years, I don't know. And it now looks brand new and real time in Max. Some Lisp purists will tell you that this is not Lisp. It technically it isn't, and there are some things you definitely can't do. I know, like Marco Stropa, for instance, will tell you that it's limited compared to what you used to be able to do with Lisp. But let's move on. This is what it looks like. So Lisp is about lists, as I said. So maybe, no, you're not able to see my arrow moving on the screen here, are you? I don't think, no. So it's okay, I will just talk through it. So, yeah, in other words, the different levels of square brackets at the bottom may be represented as tree structures, which can be manipulated within the Max environment. So here we see the add chord syntax. So a message to a bar.roll object, which will add one note in the second voice of the score, because this is voice number 2. At the onset 1000, so at the first second of the score, pitch middle C, because it's all in MIDI cent for quarter tone purposes. So basically the middle C piano, and the duration will be about 5 seconds, yeah, 4, 6, 4, 1. The velocity is maximum 127. And then even further down the tree, at the bottom right, you can see the slot content. And to me, that's what's most interesting about Bach, is it's really going way further than MIDI in my view, because you can attach to each note metadata to whatever you like. So here's a little video about what those slots. So there, yeah, metadata. Here you saw the speed at which an audio sample was played, then the seek parameter, like seek in SF play. Then you have this respect parameter. In my case, that's more for vocal formants. I use that for voices, so voice synthesis. Then you have the path of the sample to play, the size of the display node, the volume or dynamics, the text to display. I don't know, the color. You could really add many things, the things you need for your maquette or for even your score. But better than hear me talk, for those who don't know Lisp, just again observe the tree structure and look how it translates in the lists below. So again, going from up left, describe path parents, like what did I want to say? Yeah, so you have add chord 2, and then up you go down a level. So you open a parenthesis. Then now you have onset 1000, and then you go again down a level, and then you have pitch, duration, velocity. So that's the second level of the tree thing. And then even further down, the slots content. So that's the 1, 2, 3, 4 level. Yeah. So already now you can try to think, if I want in that tree to retrieve the pitch, so it's in the third branch of my tree, then I go to the second branch, 3, 2, and then I choose the first, the pitch is the first, so it's 3, 2, 1. So if I ask for the address 3 to 1, then I will get my pitch, which is 60 or 6000. So yeah, maybe now let's just indent all this. Oh no, it's not this slide. Shit. The article also describes how I used the Bell language. So I'm not at all a developer of that, but as it happens, now it's got my name, and it has not much to do with me, but still, Bell, B-E-L-L, is Bach Evaluation Language for LLL. So I'm really feel like it's my duty to explain what Bach people have done there. It's Andrea Agostini and Daniele Gysi, Italian composers and developers. So let's read that. The Bell language is mainly exposed in Max through the bar.evil object. It sounds like bar.evil, if it was evil. It's fun. X1, X2, it's correspond to the different inlets of the object. So bar.evil makes the construction of Lisp inherited parenthesis structures much easier than with the data flow Bach-ROP system. So yeah. So to show two basic rules, as I said, the X1, X2, you see there the inlets at the top. So first inlet is for the onset. If you change the value of the first inlet, then you will, if you increase it, you will start your note later in the piece, etc. So it's a bit like the exp object in Max, or I think of it also as, say, combine or printf, those things that allow you to format messages or symbols. So let's say that it would be yeah, convenient way to format messages. Here, you'll notice the few backticks in that bar eval line. Yeah, you have backticks like little tick like this, tuck, 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 and they. I will not explain in great terms, but basically it asks Bach to escape the Lisp structure. So we will just output add chord as it is, symbol following black tick as it is, without evaluating it, so as to be able to read it in Max afterwards. Let's have again a look at the tree structure, and each time you open a parenthesis, as we said, you go one level lower in the tree. We got that, huh? Onsets, you go down, you go to pitch, duration, velocity, you go down, and you go to the slots very at the bottom. And here is my slide where you see it in how it looks in code. So try to see again, where's the onset? Onset is like 4, 2, 5. And then you go down the tree, down a step, and then you get this pitch, duration, velocity, 59, 1100, and 65. And then you go down again, and you get all this slots content. So that's the first half of the screen there. And then you get another note. This is another note that the second note is at 2.5 seconds, yeah, 25. And it will be on near middle C, pitch, duration, velocity. The duration is very short, and velocity 65, like normal. And then you get all these slots. So you see that it's a violoncello piece. What I'm doing in this note, I'm putting cello samples to play with comptimbre, because I'm very rich this year. I just did a residency, so I could buy comptimbre. If you can afford it, do it. This is great. It's a big library of all the samples you can imagine. For the cello, you will have thousands of different écrasé samples, like and very German style, but great, really nice. Yeah, so I just like to stay on this image a long time because I feel it's better than me talking. Okay, we've had this, and now I'm going to try to prove you why it's so useful compared to Bach as it was before that Bach Evo language. That is just very new. It's just this year. So before with Bach, to do messages like this with all these parentheses inside parentheses inside parentheses, well, the only way you could do this was with wrap. When you add parentheses on the sides of an expression, of a list, sorry, then you call it wrap. Then if you put something before, you will need to prepend. If you put something after, you append. And to do this, you need like 5, 6 boxes, whereas here you have a single line of code. Let's see in the old way now. So, oh no, what, yeah. Well, yeah, that's the old way. This is an example by Agostini showing that it was so difficult. You get a patch within a patch within a patch within a patch within a patch to finally do some simple FM synth. So that's the way Agostini find the bell language much easier now. And the way I would explain it to you is that you had to append something and then put parentheses on both sides and then append against something. And as you know in Max, every time you do one of these boxes, you have these priority issues. So it gets, well, error prone. You multiply the possibility to give errors. How's the pace? Maybe, do you want me to speed up or slow down? Or since where's the chat window? Sorry, chat. Are you falling asleep or please tell me. I can see messages now. So, and okay. So in short, no, I've said that already. But basically, I think, yeah, it makes it easier and you have less stuff to debug. And for me, it was clear that this single line I showed you really made it a lot easier. Another thing I wanted to show here, I showed you a 2-note score in the previous slide. And why this 2-note score? Because I'm really following the path that Daniele Gysi showed, which is to compose from databases. So to go in that AI sort of era. I mean, I have no idea really what AI means, but at least to think a bit more like computers do, what they know how to do better than us computers. They can see the features, the different features of a single atom, and tell you, okay, this atom is high, it's low, and these are all the features I have in my machine. Sometimes I can find my arrow, sometimes not. Sorry about that. But basically, see at the top of my screen, top left, pitch, duration, velocity, breakpoints, program, amplitude. So there so many different ways to measure that tiny bit of score. It's really it's not a score yet because it's just 2 notes with a playing technique and a dynamic. It's really an atom. And so this atom is then, you can see on the right, you can see it's got a pitch, it's got a duration, it's got a velocity. Some I didn't manage to do yet, or I'm not using, like the color, I'm not using the color. You got all the dynamics, so it's a pianissimo, crescendo molto to sforzando. Lyrics, there's no lyrics here. Lots of things are empty, and that's probably not very clean, but at least it shows you what I'm trying to do. And then at the bottom right, you get the content. And now I think we're going to see the content. Yeah, here. So here again, the score, a bit like I just showed you, actually, I explained that already. So you see that this is a tiny score of 2 notes, but the idea is to get like, now I have in my database, I think 250. And then it gets interesting. It's really, I'm experimenting now because like last week, I had only 50. And you hear that in those AI conferences and stuff, they tell you AI, you need data, you need data. And I just see this. It's true that with 50, nothing so interesting was happening. But now that I have 250, and I have something in that register with that kind of, say, pizzicato, it will find all the scores all together. It's beginning to do very interesting matches. And yeah, I will try to give an example. Yeah, so this is a video of what I've recorded that yesterday, so it's really in the process. So this is one of the scores, one of the tiny scores. Yeah, you have 5 notes. And what I'm going to do is I'm going to query it. I think it's this query. So it's asking everybody that is around 75, so it's that register. Duration 500, that means the first note is always less than 500. Order by centroid, so it should go little by little higher. Now we're around 60, yeah? Around middle C. The centroid is the mean between different notes. It's wrong because it's harmonic, but anyway. It's around middle C. Now we're asking for a bit lower, 58. 58 is actually a name. So it's found all that is at 58 exactly. I'm querying everything that is a little higher and a little lower than 68, but it's found only this 58. Sorry. We're here. So the project is about Schumann, so these are quotations by Schumann sometimes. 77 now, we're in the high register again. Now very low. Yeah. Spread means that it's big. The spread is the ambitus. We need a big ambitus, so it's found only stuff with a large ambitus. And as it turned out, I only wrote pits with large ambitus. That's all I did so far. So it's only found those. And now, duration small. Duration is not great because it's only the duration of the first note. But 83, yeah, we're very high. 83 is the... Well, basically, yeah, what I'm discovering at the moment is that, yeah, AI, well, it's not AI yet, but basically just a query, as we query on Google that we want images of cats, computers are very good at finding all those, suddenly that they all match these criteria. And yeah, I'm finding that nice at the moment. Now I'll play you just a little video and you'll hear my recorded voice. Hello, I would like to share my first attempts at using techniques inspired by AI and machine learning to compose instrumental music. I have here a machine which generates instrumental music according to a list of 11 parameters scaled between 0 and 1. The first step consisted in saving some presets according to my taste in order to build a small dataset. Then, for classification purposes, I've tried to let machine learning tools classify or cluster those examples for me. For instance, my tweaking of parameters can feed an SOM, a self-organizing map. But so far, the most efficient method consists in representing data as discrete points on a 2D map with x and y as parameters which I set myself. Each of these points or presets corresponds to a type of instrumental writing tied together with a harmony. Here the ones on the top are in the high register, and the ones on the left have longer duration. Interpolation, which AI is very good at, was a concept of great importance for the spectral composers of the 80s. Therefore, I first tried to generate passages like this one, whose register clearly gradually falls from high to low, and which corresponds here to a gradual change of the tessitura parameter. To do so, I used an object called MLP, Multi-Layered Perceptron, one of the building blocks of AI. This object takes as input the lists of parameters together with the x and y coordinate values. This relates to supervised learning in the sense that in unsupervised learning, the algorithm would have to find x and y itself. This object is then used to interpolate between presets in a similar way as could have been done with Pattern in Maximus P. Finally, if a particular way of interpolating between presets is found of interest, it can be recorded in MUBU, short for multi-buffer, to keep track of the evolution of each parameter separately.
Okay. Now this is vocal music, so it's a different track. It's for automatic polyphony generation, mainly formalizing on a given harmony things like density, speed, whether voices sing homorythmically or if it's more contrapuntal, or which words are sung, dynamic contour, and the like. So yeah, it's based on the idea that in Renaissance music, more than register or stuff, it's really about, are they playing together or are they playing one after the other? Like here, is it contrapuntal like this, or is it like everybody at the same time? This is the main vector of contrast in early music, I think, in 16th century. Yeah. I also use Bach to automatically cue singers with what comes next. So the singer first hears an anticipatory cue and then sings along with an audio guide. I think, yeah, this is pretty clear. Basically, you repeat and then you listen. Through smartphones, I do that. And Bach, and well, Bach evaluation language again, Bell, allows me to do that in a very automatized way, according to the duration of the pause between each intervention of the singer. Basically, the idea that every time the singer has nothing to do, I need to automatically give in his ear, hey, you're gonna sing this next. Using a system of automatically generated markers. The first step consisted in iterating through the whole score in each voice, measuring the distance between phrases 2 by 2. Here the distance is displayed in yellow. Backticks, again, I've talked about that before. Maybe I should go a little quicker. And,
so here is how it's implemented in Bell, short for Bach Evaluation Language, to anticipate,
Then we paste the cue just before the next phrase. If, on the other hand, the singer has only a short rest, we pass the cue as soon as the previous phrase finishes. Similar methods are applied to page turns. With animated notation in particular, one has to make sure the page turn doesn't occur in the middle of the phrase, and so on. So now, to give a quick overview of what I do with it, well, we just saw the very tonal Vedi trompetea passage. In general, however, the harmony is more driven by spectral techniques than that. In this particular piece, sounds were synthesized in MUX, a VR interface, which, among other advantages, makes gesture to sound mapping really easy. So MUX oscillators were then recorded in order to analyze their pitch content, on the top of which I then built the polyphony. In Common Ground, similarly, the polyphony is built on the top of synthesized sounds, realized with the synthesis toolkit, RAS, Blowtar, and the like, via Percolate in Max, or with FFT-filtered FM spectra, like in this example. You'll notice the choreography is realized in InScore using the spat notation of Bach slots. You've also noticed the HMDs for singers, which is something I started doing last year in the piece Mit allen Augen, publishing the results at NIME and Tenor 2019. I believe it opens doors to interesting situations in performance. Technically, all the scores are synchronized by Smartvox, whose Tenor 2017 remains the main reference. It is a form of NMP, Network Music Performance, synchronizing all the scores.
Oops. Sorry, I wanted to get rid of those.
So
backticks.
here is how it's implemented. The goal is to interpret.
We saw that.
You notice towards the end a harmonic shift as well as a change in instrumental writing. More notes and the flute. The Emma Star library features.
Maybe which one? This one? Yeah, this one I like. Sorry, because it's very clear that it's going from low to high register and slower and slower.
This one is pretty self-explanatory, going from low to high register, forte to pianissimo, and ritardando. In those two last examples, although harmony is still very important, the gradual changes of playing techniques, texture, and register seem even more directly perceivable.
Okay, I can't stand those backticks.
So now to give a quick overview of.
And we saw that, yeah. So here sorry, maybe I wanted to
Timbre library in particular. The starting point consists in recalling that a computer-aided composition patch yielding a score with only pitch and rhythm will be of little use, say, to a German post-Lachenmann composer who would like to formalize instrumental techniques. I therefore built a sort of dictionary with each playing technique and its corresponding symbolic display for each instrument. Here is an example of the sub-batch generating the flute part. Again, the few lines of code written with less random object, with the ability, etc. First step is that this. Um, yeah, I think you got this idea of the features, yeah, the different features like the speed, duration, and so on. So this one is pretty okay. So let's listen to a bit of music, basically. I wanted to show this piece because it's a piece on the poetry of my father. So I thought I'd stop talk about tech and code and just read the poem and then we hear the music. The distance is filled with blades of grass. Where I stand, nothing seems to be growing. The cracked earth is hard and dry as shards of balls, used long ago, half buried now. And let's hear the piece. That's something that was performed in Australia. Uh, and as I say in the article, it's conducted by a Raspberry Pi because basically it's a server sending information to the phone of the singers, and the server is just a computer of the size. No tech. It's now the second half of the poem. I thought I'd play the whole piece instead of in those conferences. Usually I just play glimpses and bits of this, bits of that, and I like Morten Feldman very much. I don't know if you can hear that, but he talks about scale, and when we think, say, of Rothko and painters like this, it's the same for a painting. It's just over time that things get their meaning. So we'll play the whole piece, even I don't know if you think that's boring. As John Cage says, if you think it's boring the first time, listen to the second time. It's boring. So growing instead of weeds, the harvest of the past, and everything fallen from my hands, and yet the skin was soft, the eyes were deep as older seas, the mouth ripe as fruit. A violet and swallow traced sky slides into the place of morning, like some passenger on an early train. His ticket entitles him to distance in the diurnal ways of himself. His destination follows the railhead of being. I think still I will keep talking a little and not play the end of the piece because for just to keep with time. There's an article of the same name at that conference I was talking about before, Tenor, where I describe also the artist collaboration aspect of things. With the painting, with the costumes, with the salt on the ground, and all that. We did that before COVID, so the resemblance with COVID is just fortuitous, or what's the word? What do I have to say as an important conclusion? Basically, what I do in nearly all my pieces has to do with that technology, Smartbox, which is, the idea is to distribute scores on the phones of the singers and also possibly on the phones of instrumentalists. But it's more obvious with singers that they just know what to do and they're confident and they act, and that's more
network music performance,
more synchronizing with this. Yeah, let's see how the app works. At the moment, I say it better on the...
As stated in Tenor 2018, audiovisual scores and parts synchronized over the web. It works on the web, as you can see in this demo. However, I believe it remains important for me that the performers are located in the same room. So we are on the local Wi-Fi here, rather than the internet. For the second part of my talk...
Okay, that was in Sevilla. That's a project about Jardín de las Delicias, Hieronyme Bosch. We saw all that already. Yeah. Markov chains. I haven't talked about Markov chains, but the little thing I described earlier, that was based on Markov. Whoops. 3 minutes. What? Are there any questions maybe? Because I don't think nothing is like... this is in Australia, an interesting, the Elysion using AR scores, and that inspired me quite a lot. That was last year in Melbourne. This is my thesis, in which I quote Aaron Cassidy. I quote his piece, "Eye purple, spat blood, love of beautiful lips." Because in that piece, I hope he's going to show it to you in half an hour. It's a great, great piece, performed by one of the guys of Elysion, the clarinetist who also sings. Elysion, sorry. He's got an audio score. That's what I talk about in my thesis. And I'm very happy to see people quoting my work now. So audio score, basically, the idea that the singer hears what to sing. And what's interesting in his approach, in a way more forward thinking than mine, is that it's a max patch generating something in live. So the singer has to respond in real time. And that's something I'm trying to do, although for me, it's also good for a performer to know what he has to do. They sort of like to, that's sort of the problem for me with live generated score. That's what Bach is almost made for, but I don't use it that way still, because I think it's good to treat performers as friends and not giving them something too hard to do. Like if they have something suddenly popping up on their screen, yeah, that's us. But still, please listen to "Eye Purple, Spat Blood, Love of Beautiful Lips" by Aaron Cassidy, because this is a masterpiece. I think this is good as a conclusion. So thanks a lot.